Hello everybody and welcome back to Calculosity with your host Corey. Now today we're going to be talking about different types of discontinuities. So as we've discussed previously, I've mentioned asymptotes and jump discontinuities, but we're going to deeply dig into the topic of discontinuities and figure out what makes something a discontinuity, what different versions of discontinuities are there, and then we'll be better prepared as we move into the actual calculus of differentiation and integration and things like that. So let's kind of dig into it. Now previously we've looked at several different graphs and we've seen a couple different types of weird behavior. So let's start with something that we looked at really on the first lesson, and that is an asymptote. So an asymptote is a type of discontinuity in which one side goes in one direction and the other side could also go in that same direction or go in the opposite direction, but the idea is they're moving towards infinity really quickly. So something like this. That is an asymptote, a vertical asymptote specifically, that's going to cause a discontinuity. Because notice that the left side never ever makes contact with the right side. So there's this big jump in values from positive infinity straight down to negative infinity almost immediately. Well, immediately, frankly. And so that's going to cause a discontinuity. There are other types of discontinuities as well. I've mentioned removable discontinuities. Those occur when there's a hole in the graph, and that value could be transplanted elsewhere. So these are two really important discontinuities, but there are also other discontinuities as well. Things like jump discontinuities. That's when all of a sudden the value changes. So in the first case, the limit of the left-hand side and right-hand side are not equal. We have infinity and negative infinity. In the second case, with the removable discontinuity, we have the limit on the left side and right side are equal, but the function value is different. There's a piece plucked out of it. In this third case, we have the left side limit is equal to the function value, but the right side limit is not equal to either of them. So these are particularly common occurrences, common discontinuities that cause some issues. So let's label these guys. This first discontinuity is an asymptote, specifically a vertical asymptote. So a vertical asymptote is problematic because we have this big jump in the graph. Now this one up here is a removable discontinuity. And that just means that there's kind of a hole plucked out of the graph. And then this final one over here is a jump discontinuity. And that is when there's this big, leap, this big jump. Oftentimes we'll see the jump discontinuity in the form of a step function, which is something like this, where we have pieces that just step upward, kind of like a little ladder there or a staircase. That's something we'd see with the floor function, the floor of x, which actually just means rounding down all the time, and also the ceiling function, which means rounding up all the time. And that'll cause jumps like that as well. But we don't have to worry about those functions. Those are not going to really appear in calculus. But these particular discontinuities are very common, the ones that we see here, and we need to be prepared to handle them. So what makes these discontinuities? Well, like I said, they become discontinuities when you try to run your finger across the graph as if you were walking on a road or you're on a roller coaster and you're in a cart, and all of a sudden you encounter an area that you can't continue forward. So that's obvious. If you were on a roller coaster and you encountered the first type of discontinuity, you would be scared out of your mind. And so think of that fear as a discontinuity. As you encounter that second one, there's a big hole in the track. You cannot continue further. That is a discontinuity. And that last one there, well, that's bad news. There's also a hole in the track. That's a discontinuity. It's really any time that you can't move your finger forward without picking it up off the graph. That's whenever you're encountering a discontinuity. So just be prepared that these are discontinuities and they cause weird behavior when we're doing limits, and you'll find when we're doing derivatives a little bit later on. So be prepared to handle these guys and to encounter these guys should they come up. But that being said, let's continue forward and explore a little bit more about continuity.